I'm actually from an Arconic family. My father works at our Iowa location, so I was always interested in engineering and specifically in metals. When I graduated high school, I went to Iowa State and I already knew I wanted to work with metals.
I don't know, like the whole getting to mix different chemicals or making a volcano, as a kid in elementary school, that was always really interesting. And just trying to figure out why things happen.
When I was younger, I don't think that I thought that I would be a scientist, even though I had an early interest in science. I lucked out, and when I first went to college, I had a teacher that kind of encouraged me to develop my talents when it came to science.
My degree's in material science and engineering. Yeah, so I didn't even know what it was when I went to college, but I really liked chemistry and just science in general, so that's kind of what led me to material science. There's something a little different. So I think it's really cool that we get to make cans and automotive parts and things that are actually used on a daily basis in pretty much everybody's life. We get to do a lot of problem solving, which is really neat, and just understanding what's going on and what all goes into making those things that people just kind of take for granted sometimes.
When they bring the metal in from the recycler, we have to melt it down and test its properties to see what all the elements that are in that metal so that it can go on to the folks in the ingot plant.
We start out with a giant ingot like was seen at 25 to 50,000 pounds. We then put that into what we call the preheat furnace, which is just a big oven. It heats up to over 1,000 degrees, and then we pull it out and we roll it across those setted stands. During that time, we take it from a 20-foot long ingot to over a mile in length, and that's why we got to coil it up.
And after they've milled it, they've squished the metal and they've made a big roll out of it, then it comes back to me again, and we put it into our robot testing units, and we put special samples into it, and it pulls them apart, and it's imperceptible, but it's measuring exactly how much force it takes to break the metal. And that tells you a lot about the physical properties of the metal and what you can and can't do with it. And so I get to see everything from start to finish here, which makes my job pretty special.
Yeah, and it's really neat because even amongst aluminum, there are so many different processes that we use. If you scope out, it's mostly either you're heating up the metal or you're mechanically working it. But even just those two levers create numerous processes that do everything from making cans, making cars, to making rockets.
Take every opportunity they have at school, get involved in science fairs, get involved in a science club if they have one at school, and then this is the hard part. They have to do the ugly hard work too. So they've got to study hard, and they've got to learn math. Learn algebra really well so that you can learn calculus really well, so that you can learn linear differential equations really well, and it all builds, everything builds from the bottom. It all starts at 1 + 1, and then next thing you know, you're doing very difficult math, and you're working in a lab, or you're doing something that's really cool. But you have to start with the basics.
Get involved, ask questions. Every time you look at something, as someone who studied materials, everything is made, right? With the exception of the trees and the ground, etc. We're taking stuff up out of dirt and we're turning it into objects. And for every object that is man-made, you can ask, how do you make that? And there's an answer, and you can find out that answer by looking it up online, taking a class. Just really dig in and try to understand the world around you.
Keep being curious and trying to figure out why things happen around you and understand what's going on.